Hi, pre-calc students. Let's talk about intervals of increase and decrease. Why? Because most of you, I'm talking to my students, most of you basically understand this, but are missing some little details. So I understand that you get most of it, but I'd like you to follow along with me and make sure you get all of it. Because some of the things we do with intervals of increase and decrease, we're also going to do with other things. It's not going to go away. So let's talk about, basically, first of all, what are we talking about when it's intervals of increase and decrease? We're looking at a function, and we are traveling across the function from left to right. Okay? And I like to think of it as I have a little guy walking across the function from left to right. If he is walking uphill, just like a positive slope, he's at an interval of increase. If he is walking downhill, let's say he's sliding downhill, that is an interval of decrease. It is all in terms of traveling from left to right across the graph, and he's standing above the line, so don't try to put him up underneath hanging upside down. Keep in mind that this is very different from, well, and I say it's very different. It's similar to, and this is why it's confusing, it's similar to but different from end behavior. And the big difference with end behavior is, in behavior, I'm just looking at where does this point, where does this point, where do the ends point. This is not in behavior. I'm not talking about that here. I'm talking about we are definitely moving from left to right. Okay, and we are looking at whether he's going uphill or downhill as he walks across this shape. In order to do that, we need to find the turning points. Every time you have a turning point, whatever he's doing changes. Uphill, and then now turning point downhill. So increase, decrease, turning point. He was decreasing, then he got to this turning point, increasing. Gets to another turning point, decreasing again. So that's the big picture. Now, the things that we need to look at in terms of details that get lost in the shuffle. One is, by the time you get to pre-calc, generally, we like to describe our intervals in interval notation. So some of you need to practice that a little bit more. So I have before me 3 number lines. Interval notation is describing stuff the way we think of a number line. It's describing it in order of the number line. So for instance, in interval notation, just like negative infinity is to the left of the number line and positive infinity is to the right, if there's a negative infinity involved in your interval, it's going to be on the left. If there's a positive infinity addressed in your interval, it's going to be on the right. Everything that happens in interval notation is in the same order you would see it on in a number line. Smaller numbers to the left, larger numbers to the right. That does not change at all. So let's think about an inequality, excuse me, which is how you originally first learned to represent a range of values. So let's say I have, this is 0, and I have, my graph is going to be shaded this way from the point -2, and it's going to be shaded to the right from +3. Okay, first thing is, let's talk about how this works in inequality form. Okay, when I'm talking about this as an inequality, let's say that our variable is x. Our variable could be anything, because we use these intervals to describe things about x, things about y, things about whatever. All right, so this says x is less than or equal to -2. This says x is greater than, but not also equal to, 3. We fill in the circle when we mean it can actually be that point, and we do not fill in the circle when we mean everything right up to that, but not actually 3. So this is like 3.00001 is a solution, but 3.0 is not. Okay? So interval notation says I'm going to just change this and write it, really, if anything, it matches the number line better than this does. It's harder to learn to write this from the number line than it is to write interval notation. Interval notation says, okay, I have an interval here. I have a range of values. On one side of that interval is negative infinity. On the other side is -2. Okay, so that's my interval. Now, With negative infinity and positive infinity, we always use a parentheses because that is saying does not include. That's like an open circle. You cannot include the number infinity because the number infinity doesn't exist. It's not an actual location. You cannot go to there and stop on the number line. So therefore, we don't say it's included. All right? On the other hand, if it is included, if your number is included, which negative 2 is here, just like having an or equal to here, I make a bracket. So if it's less than or equal to, or if it were greater than or equal to, I would have a bracket for that number. Infinity symbols always have parentheses. Over here, and again, it really fits the picture much better than an inequality does. On the picture, you have 3 on the left, infinity on the right. That's the same thing your interval says. 3 on the left, infinity on the right. Now this time 3 is not included. So even though I used a bracket over here, I will use parentheses over here because 3 is not included. That's what the difference is. Parentheses are for use when you don't include the point or when it's just plain less than or greater than. Bracket is for use when you do include the point and it's less than or equal to or greater than or equal to. We always put parentheses with infinity. And so that's my answer basically. That's what this graph, this solution, I guess you would say, this solution set, or this set of numbers really, is notated in interval notation like this. Now, since we're talking about this and this also, altogether, we usually put a union symbol, the union of those two pieces together. And that's how I would describe that number line graph with interval notation. Okay, let's look at one that's talking more like between two numbers. Okay, let's say I have 0, and this is negative 3, and this is positive 5. And I'm going to talk about a solution where it's from negative 3 to positive 5, not inclusive. Not inclusive meaning not including those points. Now, as an inequality, I would write this from negative 3 to positive 5 and no equal signs on either of these. Okay? When you write a compound inequality like this, remember we always write the inequality symbols pointing the same way. Pointing to the left, meaning less than, because then we can put the numbers in number line order. Less than, smaller numbers on the left, bigger numbers on the right. This actually looks a little bit more like the picture than the ones that we had up here. Okay, so that's what that looks like as an inequality. As an interval, this is all one interval. It's one section of the solutions. This is the range of numbers. So we're just going to say from negative 3 to positive 5. And then we have to decide on parentheses or brackets. In this case, I don't include negative 3, so that's a parentheses, not a bracket. I don't include positive 5, so that's parentheses, not a bracket. And that would be my answer. This describes that number line or this inequality. Sorry that my dot cam likes to blink. All right, let's look at one more. Let's say we have a graph like this. This is what we're dealing with when our range of numbers is pretty much everything except for one excluded value. In other words, all real numbers except for, in this case, that would be negative 2. All right, so if I wanted to write that as an inequality, I could say x is less than negative 2, or x is greater than negative 2. That's what I could say. As an interval, basically you have two separate sections. Anytime you have a break in your interval, you're going to have a new set of parentheses and brackets. Okay? So this is a break in my interval. X cannot be equal to negative 2. So I'm going to have a set of parentheses slash brackets, you know, an interval described over here and an interval described over here. All right, so over here we have negative infinity, positive infinities here. So we're going from negative infinity to negative 2. We don't ever include negative infinity or infinity, so we just put parentheses here. This time negative 2 is not included, so we just put parentheses here. Now this section over here goes from negative 2 to positive infinity. Negative 2 is not included. Positive infinity is never included. And then we just say, I mean for all of this to be my answer. So I put a union symbol in there. This is basically like saying my answer is in the collection of this set or this set. All together, one of these places is where you will find the answer. We do this a lot. If you had several excluded values, you might have several sets of parentheses and or brackets. Really, if they're excluded, that would always be parentheses. It would be hard to have an excluded value. It would be impossible, really. But you might have something weird going on over here that would cause brackets because maybe some other number's included. Who knows? Maybe there's a bigger gap, like maybe... I'm just going to randomly put some numbers. Let's say this is negative 3, and this is 2, and this is 3. What if it went like this? Well, then my graph has 3 different sections. I have the section from negative infinity to negative 3. And I have the section between negative 3 and 2. None of these are included yet, so all of these are just parentheses. But I also have a section over here that starts at 3 and goes to positive infinity. And that one includes 3. So that's what I was saying. You might have a bracket with something else going on. All right, now I'm going to cut it off here because that's long enough for a video, and then we're going to resume and this time talk about how do we actually write the intervals of increase and decrease in interval notation from a function in terms of looking at its turning points and how we would write these.